So, hi everyone. It's great being here. I hope you enjoyed lunch and we'll have great time during this session. I'm Eynav. I'm VP R&D at Oribi, but my real job is being a mother of these three punks here. Today, I'm going to talk about how to effectively evaluate and plan a data solution for your system. So first, I want to ask you, why bother? Okay? Because there are so many data solutions out there, and sometimes it seems like any day a new data solution is going public, and probably we can just think in general what we need and pick something. It will probably work, right? So eventually, it's not the situation. We've experienced something like that at Oribi, and I'm here to share that with you and hopefully to help you to learn from that and make things better. So Oribi, just in few words, so you will have the context of what we're doing there and why we have so many data solutions and data practices. Oribi is a startup based in Tel Aviv, 5 years old now, and we are collecting data from our customers' websites, tons of data with high scale. Every event that is running on the website is getting to our backend, where we create insights and visualization for that, and eventually enable our customers to export this data to other platforms. Okay, so that's it about Oribi. Feel free to read our website. I'm sure you will. But moving to our topic. So Oribi is a big data-based solution with more than 300 million events incoming per day. That's a lot for a startup. And this scale is sometimes going crazy up and down. For that, we have an auto-scale system, optimized infrastructure with many solutions and data solutions. I want to focus on one specific solution that you can see here, this tiny elephant, Postgres, if you are familiar with. Postgres is an RDBMS data solution that is a great one, by the way, for several specific use cases. At Oribi, a few years ago, it was used for, surprise, a POC. A POC to create this amazing feature which called funnel. If you don't know the term, funnel is illustration where we want to create a graph of all the people that did A and then did B and then did C in a time series way. So we did that as a POC on top of Postgres. It worked okay on the POC. On production, it was okay as well, but in some time where we scaled up enough, it got really broken because this is a heavy computation to do on top of an RDBMS system like Postgres. So when we did that, we actually had 10 million incoming events per day. Today we are 30x more than that, so that's a big difference. It was a POC, and it was used, as I mentioned, for heavy computation. Eventually, what we did have, after 2 years where the startup succeeded and we win and everything go well, multiple writes with heavy read because of this heavy calculation. Add that the traffic scale, and boom, we got a major mess in production. Queries went and took a minute and more to calculate one funnel. That's a lot in the world of FOMO, where all of us want to have all the data instantly. 1 minute is too much. And it didn't carry up the scale. So what should we do now? That was a serious thing because the customers really liked this feature. We won velocity, right? It was a POC, went really quickly live to production. The customers had great feature, but we lost in performance because it really didn't get with the scale and with the traffic, and eventually it created more problems than actually wins. Reality check, okay? So why such things happen to us? Why do we encounter such data solutions that do not fit the actual goal that someone planned? First, resources. Usually we don't have the resource and we don't have the budget sometimes to think out big. Knowledge. Sometimes we don't really know what exactly is needed in our system at the point when we really need to think of this data solution. Time, we never have time, right? Like as developers, all the time, everything. People make us to do stuff fast and faster, so never, the time is never enough. Over-motivated developers, the people that I know how to do it, just let me do that in production and no need to plan too much, and so on. I'm here to help you learn from our lesson learned. Today, we are acting totally differently in our system. We invest a lot of effort and time and think of how the data solution really should be. And that saves us a lot of time and make things really work on production. I'm going to share 3 pillars that will greatly help you with your data solutions. The first one is business value. The second is really looking into the performance requirements. And last, overthink future plans. Let's start talking about the business value. In terms of business value, there's a lot of parameters that you should consider when you plan your data solution. That most of the time it will take more effort from us, right? Because most of us are not business people. But it will be really helpful if you can invest the effort and mindset to understand what your business really needs. First, let's talk about scale. All right, everyone talks about scale, okay? Right, all around that, scale, scale, scale. So let's talk more, take it more to the ground and talk about something that is more measurable. How do we plan our data solution to fit the business scale plans? So there are several vectors for that. The most common one is the customer base. How many customers should this data solution support? X, 10x, 30x. That's an important metric that you should be aware of when you plan this data solution. The second one, and there are more than 2, but just for this specific simplification, the second one is the usage. Per the usage, sometimes the customer base won't change so much, but the usage will grow. We had such situation at Oribi. As you can see, at the beginning of the year, we went 3x only with usage. So our customer base didn't change in that pace. We have a lot of customers and it went well and it's still going well, but not in that ratio where the usage really ramped up. And that affected our system because customers are more logging in, using the system. There are more queries. There are more query load at the system because we are analytic tool. So we predicted this ramp up and scale. And we did a change in the system that eventually gave us a lot of oxygen for the next year. So this is Oribi in a nutshell. I want to explain shortly what we did. Of course, that's not the system. We have 100 microservices and everything is complicated and fun. But just to explain how we did the change to support the increased usage of the system. So the left side is the ingestion flow, where a lot of data comes inside our system to Oribi. At the middle, there's Elasticsearch and Apache Druid, Borg, FAR, monster data solutions that really help us digest the data. A lot of writes in real time. On the right side, we have the query services and the UI that eventually gets the data from this data solution and reflect that throughout the UI components. Having the incremental scale in production for the ingestion and the 3x of the usage really created a bottleneck on the right side because more queries were created, and that created some kind of a load on that system from both sides, ingestion and query. What we did to avoid a mess or a degradation, we split the query from the ingestion. The ingestion continued to work as is. And for the query flows, we added a batch processing separately on top of data lake. So all the query was on top the result of the offline processing and not on the Elastic and Druid, and a lot of load was reduced from this data solution and eventually got us the air to continue and have the great performance. Few takes from that. When we look on the business value, there are several parameters you should take into account. Scale, we talk about it. Try to even get deeper in the scale to see not only customer base, but also other metrics like the usage. Go to market, sometimes the business will change in the way that can affect the data plans. For example, if you are now working with small, medium-sized business and you are going to move to corporate enterprise, that will have a major effect on your data solutions in terms of load, traffic, and sometimes also security and other consideration. Product requirements. I showed you before that we moved to use batch processing and offline for the query flow. Part of you probably thought in your mind, well, but that's different. It's not a real-time query flow. It's not. We moved to offline query flow where the data freshness is not a real-time one. It's an offset of 30 minutes. So that needs some product discussion to have this discount, to have this flexibility. Try to think with your product, do you have this flexibility and what exactly are the product requirements for the feature that you are building with this data solution? And eventually, future costs. Sometimes when the business will evolve, the cost will be affected as well, most of the time. So we want to know that we won't get a too high cost. But I want to say that from the other hand, sometimes we are in the middle of a great business deal, something investment in the startup, and you want to do something big and fast, and then you will be taking an expensive solution that will give you everything but a bit more quickly because you want to show the impact fast. So on the cost for the taking the more expensive or the lower cost, you should be also attached to the business value parameters. We talked about the business value. Let's talk about performance. In general, I think that as engineers, performance is the topic that is more easy for us to talk about because this is where we usually live, right? Not in the business area. But even here, sometimes I feel like we plan, we design, we think, we invest the time, and eventually there is a major gap between what we planned and what we have on production. And it's not fun, I'm telling you from experience. So There's a lot of ways to avoid that. Let's talk about a few of them. First, try not to assume, to go under assumption that what works on POC, staging, or worse, on your local environment will work the same on your production. Most of the time it won't. First will be the thing that you need to do is to think, what will be the main purpose of this solution? Are you building a washing machine or a dishwasher? Okay, and take it to the real world. I think that you can do it easily. What are you trying to solve exactly with this data solution? Then it's easy to get to the point of what will be the real load on this data solution. Is it many writes, updates, read, deletion? What will be the actual work at this data solution? Which type of resources do we need? And try here to go wide as you can, not only with CPU and memory parameter, think also on I/O, network, storage, concurrency, all the parameters that will help you to pick the right resource for your data solutions. Sometimes you will need a GPU, sometimes you will need something more specific. Do everything that you can to plan your resource right. It really will help you in terms of performance and performance under scale. Resilience and high availability. Most of the time, we want everything to be highly available, but it's not all the time such a need. So think what is the real availability that you need from your data solution and get it into action. I'll give you an example, okay? If you have a data solution, Elasticsearch, and you want it to be highly available and resilient, and you're saying, okay, no problem, I have a backup. Did you get to check sometimes how much time it gets to restore your Elasticsearch from your backup? It can get up to 6 days or more. It depends on the amount of data and the way you structured your data. So it's not enough to think that you have backup. If you want to have high availability, try to think how I'm going to restore and recover from disasters or mistakes. And also consider how much zero time you can afford with this data solution. Even if nothing happened, your production is the most best in the world. You have upgrades and system updates. Those are usually require some downtime. Can you allow that? If not, you need to talk with your DevOps. You need to talk with the data engineers. You need to mention that this should be taken into an account. And I think that is really obvious, but I feel that I really need to say that as well. Observability. Try to see that any data solution that you plan for your system is fully covered with all the monitoring from all the perspective. As I mentioned, the metric of CPU memory, concurrency, I/O, and so on, and try even to enlarge that with average query time and everything that will help you keep in track of your data solution health. Talked about business performance, and let's talk about overseeing the future plans. I think that this is sometimes the most hard thing to do for most of us. Probably most of the time we're not really aware of the future plan of the business, the system, the R&D, and we can't even try to guess it. So I'm here to tell you, make the effort to ask all the questions. Don't be shy. That can really help you eventually taking the best solution for your system, okay? And if it sounds like a storytelling, I want to show you an example that might convince you better. So Alibaba, I hope that you're all familiar with them. They started with, they had AliExpress, and that's a huge online store, right? And they are working really hard to track and analyze all the actions that we are doing on that online platform. What are we buying, what we're not buying, what we try to buy, who buys, why people don't buy. Every little data is getting into their system, to their analytic system, a lot of data that eventually they're analyzing, sometime in real time, sometime offline, but that's a main part of what they're doing. They started with Oracle, and that's probably makes sense in the time that they started doing that. Very quickly, they ran issues with concurrency problems. So they moved to another solution, not sure if you're familiar, called Green Palm. Very quickly, in 1 year, we're talking about far away, where people didn't make set changes in that high pace, but they did. They understand that the business is growing and this data solution cannot fit its goal. So they changed. It still wasn't a good fit because they still had a high concurrency issue. So they did another change. It took them more time because it was a major one. And they moved to HBase and Hadoop. So that's a major change because they were using to have RDBMS data solutions, to have all in one place, saving the data, storing the data, querying everything in real time. This was a great change, a major change for them, but they still did it because they wanted to solve the high concurrency. They understood that in seeing the future, this business is going wild and they want to support that. So they have that change, but it still wasn't enough. They had two problems now. One was consistency, because part of the system was on real-time data solution, and some part of the system was on the offline with Hadoop and HBase. That created discrepancies between the data when querying more than one data source. And the second issue, and that's an interesting one, they had a real issue with the adoption of this solution internally in their engineering team. And the reason for that, it was the learning curve, which was really, really high, going through Oracle to this solution. They couldn't support that well. So eventually they did another smart thing. And also I think it's fast. It's in terms of time, 2 years to do that, that's amazing. They created their own DB from scratch called Analytic DB that was a great fit for their needs. It solved them the consistency almost. They did a bit more iterations later, but everything was in one place. It was a SQL-like interface, so it was really easy to adopt. And they won it twice because eventually that got into their cloud provider ecosystem as a product for other customers. So a bit of what we saw here. When I'm talking of overseeing future plans, it's on us to ask questions that will help us to understand where we should point the highest for both the R&D and technology. Also consider the R&D growth plan. Who will maintain this solution? Who should implement that in the future? Do we need to hire people? Do we have the right people to handle that? Do we need more DevOps? Are our DevOps aware of this major change? Learning curve. Okay, remember, moving from Oracle to HBase and Hadoop, even if the most great solution, it might not be a good fit for your engineering group. And the last thing, can this solution enrich other parts of the organization and system? Can that be 1 + 1 = 3? Okay, for Alibaba, it was. All right, so we talk about 3 pillars that can greatly help you make the gap from going planning a data solution towards production a minimal one. Business value, performance, and overthink future plans. I hope you enjoyed the session. I will be around if you have any questions, if you want to share or you want to learn more about the case study that I shared here. And I want to thank you and enjoy this great conference. Thank you.